Hello. Oh, question already. Um, the thing that I'm going to focus on today, is obviously any questions from the maths that everybody did at the weekend. But also, what I will do is I will do a little summary of what will be on your test this weekend because I have somewhere got the tests open for each individual group in front of me. So I will look through this, as I did last time, I think, which was where I said, I think you should make sure you remember some of these things, or at least pay attention to these things. In terms of the topics on the test, I'll just get my email open that I did send to people. Um, Key Stage 3 and year, well, Key Stage 3, so year 9, who's out of the people that are here, um, are have got biology topics on disease and photosynthesis, chemistry topics on energetics, which is like endothermic and exothermic reactions, and organic chemistry, which is the crude oil and all that stuff. Um, Physics, we've got forces mainly. There might be some equations stuff in there as well. In maths, Pythagoras, angles, statistics, and probability. And then year 10 is basically exactly the same, except for you also have the biology topic of homeostasis, which you will have done. And in physics, you had a lesson on particle theory, like specific heat capacity and those things. And in maths, quadratic equations, circle theorems that you did most recently, and statistics and probabilities. Um, right, let me have a look at the questions here. Um, there was an email about them, I can guarantee it, but I did just list them out. So there you go. But I'll make a note of them. But anyway, I'll read from the top of my head again. We've got disease, photosynthesis, biology, energetics, which is to do with energy changes like endothermic, exothermic reactions. They have these graphs that I'll mention in a minute. Organic chemistry, which is crude oil and fractional distillation, physics, forces, and equations. I don't know if there's much equation stuff in there, but yeah. In maths, there's angles, Pythagoras, um, statistics, and probability. That seems to be the stuff. Um, yeah, the post probably has been anybody who wasn't here, the post will have gone probably yesterday or today just because of the bank holiday situation, which means if you don't get it by the weekend, don't worry about it, just do it for the following week. And also, in theory, we always forget to do this, but our intention is always that the homework that you had last week, in theory, should have a 2 week deadline because you have a test, but we always forget to tell you. So it doesn't really matter. Hand it in the week after if you get it late. Right, let me start answering some questions. I will start with anybody who was answered. So I'll tell you the year 9 questions, 13 and 14. Let me do that first. So these people did stuff to do with rearranging equations and stuff. It's a revision stuff, which not everybody else is doing yet. So I'll just go through these ones first, and then um, laws of indices and thirds. Yeah, love to do that. Um, and then there's a few other questions. And then, yeah, as I say, after I've just done these few little bits, I will go through the test to an extent. Right, here is a number machine. There's an input and then there is an output. Write an operation in each box to make the number machine work. Right. Not the easiest question in the world, but decay revision. Yeah, that's maths, right? You're not talking about radioactive decay in physics. I presume we're talking about maths. Okay, but yeah, I'm assuming you are. Right. So the what I see here is that this n has had a 4 subtracted from it, and it's in brackets. Now, if it's in brackets, it suggests that, oh God, all right, biology, sorry, it's another decay. Forgot about that. Yeah, I'll try and find that. Yeah, fine. um, okay, 3 takeaway 4. So there is what we have done in brackets here is taken away 4. If you run from bid mass, you do what's in the bracket first, and then you do multiplication, all the other stuff after it. So that to me suggests that the first thing we have done is taken away 4 from this number. After we have taken away 4, we have then times it by 3. That's what that tells us. So that is the operation to make the number machine work. Work out the value of n when the input and output are equal. That's quite a complicated question. Okay, well, work out the value of n when the input and output are equal. Well, I guess all you do then is you take the input and the output and you write them equal, like that. And you try to solve this equation. So 3 times n is 3n. 3 times minus 4 is minus 12. Then well, it's a little bit of work to do here, but what I would do personally is I would take n away from both sides. That will give you 2n and nothing on that side. Then I would add this 12 to that side to get 12 equals 2n. And then I would divide by 2 and get n equals 6. Yeah, the address, I think we've got that. We got an email about the address change. I think I've seen that somewhere. So yes, we've got it. Right, that's that. That's 13. And then 14 as well was asked. So here's another number machine. -1, we're adding 7, then dividing by 2, that looks like. So if we follow this, -1 add 7 is 6, and 6 divided by 2 is 3. Here is a different number machine. Something times 5, take away 6. Da, da, da. The output is equal to the input. Work out the input. Ah, right. Okay, I guess the way to do this question is a little bit like the one above, right? If we say that this is x, and then we end up with x as well, that means that what we have done to this x is times it by 5, then taken away 6, and we've ended up with x as the answer. So I would write out like that. And then I'd solve this equation. So if I take away x, it gives me 4x. If I add the 6, it gives me 4x equals 6. If I divide by 4, then I get x is 6 over 4, which is 3 over 2, or 1.5. And we can prove that works by saying, if I did have 1.5 at the beginning, and I times it by 5, and I took away 6, I get back to 1.5. Such is the magic of maths. And that is 13 and 14, right? That seems to be everything from that one. Don't think anybody had any questions on the year 10 one, it seems, because it was circle theorems and probably not that complicated. Right. In which case, I'll do the question on. This won't apply to everybody. This is going to be quite complicated, but I will do this one. I presume it's complicated without looking at it, but there is a question that says, question 7 from booklet year 11. Okay, right. If you're in younger years, this won't be making much sense to you for now. So let me just get through it quickly, and then we'll do some surds and indices, and I'll finish with the biology decay section, which is a bit weird. If you can't see the screen, I can always recommend you go and come back, because I presume most people can see it. Yeah, otherwise they'd be saying more people would be saying something. That's the only thing I can advise. Or try it from a different device. Can you please explain the difference in how mitosis and meiosis occur? Yeah. Well, so what I'll do is I'll get through this. I'll do a little bit of surds and indices, and then I'll do this little biology, 2 little bits of biology topics, which seems to be what everything covers everybody. Right, A, B, and C are points on the circle. X squared plus y equals 36. A is on the y-axis. Okay. B is on the x-axis. M is the midpoint of AB. COM is a straight line. Okay, got a feeling this is a right angle. I can't explain why, but it is. Show that the coordinates of A are 0, 6. Okay. Well, that's relatively straightforward because the equation of a circle has a radius squared at the end, which is not the correct way to do this, but it also is, so I'm just going to go with it. The equation of a circle is x squared plus y squared equals the radius squared. If the radius squared is 36, then the radius is 6, which means that this distance is 6, which means A is the point. 0.6. So something like that for that bit. Oh, someone else saying something. Um, some questions from year 10 booklet. I mean, some a bit more precision would be good. Um, um, it's quite a lot of questions have just come in. Do we need to know? Yes, you will eventually need to know the circle equation. Yes, which is really that's it. I mean, it is just that, and then it always has a number at the end, which is the radius squared. Um, and that is a circle that looks like this. It always has the middle in the middle of the graph. If I make the radius bigger, it just gets bigger and so on. So yes, in principle, you do eventually need to know that. Right, Mendel's P biology. I'll see if I can get to that. And how to construct and solve quadratic equation. That's quite a vague thing. Yeah. Um, I'm trying to think what everybody did. Oh, you didn't do this. You did circle theorems, right? I did a million quadratic equations this week, but not with you guys. Yeah, I'll do a little bit of quadratic equations, but they might come up in a minute. Let me try and finish this question. Work out the coordinates of B. Well, isn't that also just 6, 0? I mean, yeah. If the radius is 6, then it's 6 all the way around. And so is that. Okay, there's going to be more to this. Um, Show that the equation of the straight line passing through C, O, and M is y equals x. Okay, that's quite complicated to show. Um, so they're basically saying prove that this is y equals x. I mean, which it is, but let's just try and prove that. And it's to do with this midpoint thing. If we know the coordinates of A are 0, 6, and the coordinates of B are 6, 0, then so we've got 0, 6 and 6, 0. How do you find the midpoint between 2 points? You find the middle of the x coordinates and the middle of the y coordinates. The middle of the two x coordinates is 3. The middle of the two y coordinates is also 3, which means that this point here is 3, 3. Now we have a line that's going through the center there, which is 0, 0, and another line, point 3, 3. So it's going through 0, 0, and 3, 3. The only line that goes through in this situation is y equals x because they're the same coordinates for y equals x. I suppose if you really wanted to prove it, then you could find the gradient of the line by saying the change in the y coordinate over the change in the x coordinate is 3 over 3, which is 1, which means the m is 1. And the c is the y-intercept, which is 0. So therefore that doesn't exist, leaving you with just y equals x. I guess if you had to really show it, then that's what you would do. And then work out the coordinates of C. That's over here. Okay. Well, hmm. Okay, I think I've got it. Right. So this line here is 6 long because it is the radius, another radius of the circle. It's the same all the way around. If and what I would like to find out is basically the x and the y coordinates of that line, and they're the same because it's still on the line y equals x. So whatever the x coordinate is the same as the y coordinate essentially. So what I've got there, if we just redraw that, is a right angle triangle with a hypotenuse of 6. And this side, let's just call it x, and this side are the same because it's the same distance from there to there as it is from here to here because of the y equals x line thing. And so if I was going to use Pythagoras, which everybody should know, to answer this question, then I would say that x squared plus x squared equals 6 squared, which is 36, which means that 2x squared equals 36, which means that x squared equals 18, which means that x is the square root of 18, which is it simplified? Oh, third form, and that is in third form. You could simplify that to 3 root 2 if you like, but that is the distance from here to here, which means that the coordinate here is minus 3 root 2, and it's also the distance from here to here, which is minus 3 root 2. So the coordinates of C must be minus 3 root 2 and minus 3 root 2. They must be the coordinates there, I'm afraid. Pythagoras theorem is only in year 10 and above. That is not true. because we teach it to our year 9 students, but thank you. Um, so, right, that answers that question. What else have we got then? Why can't it just be 0, -6, or C's coordinates? Because, so for C's coordinates, you're saying could it be 0, -6? Well, firstly, 0, -6 is there. -6, 0 is there. So this is not the same, if you see what I mean, right? So there's a -6 there and a -6 here. C's coordinates are neither of those. They are a bit less. Okay, so that's what we've just worked out. Okay. This foundation, I haven't seen this before. This specific, well, the specific question is not a foundation level question. This is very much on the high level booklet that we gave. However, Pythagoras is very much. So the thing with all these is, if you look at a question individually, this is or would be on a higher level paper. However, the individual things I've done, like Pythagoras, or the equation of a straight line, or the midpoint, these are all foundation level topics. The difference is it all gets put together in a high level thing. So the booklet itself is they're higher level questions, but understand that the individual things I've done, you need to know whether you're doing foundation level, like finding the equation of a line, or finding the midpoint between 2 points, or Pythagoras. Surds is not technically, but that's just the very, very last part of that. Okay, right, that is that. Right. What I will do, since I'm on the maths situation, I will do a quick recap of things related to, as someone has asked, surds and indices. And then we will, and just to be clear, if you want to, specifically for those in year 11 who are thinking of foundation versus higher stuff, the indices are a foundation level topic. Surds are not technically, but there's a little bit of overlap between the two. So if I was going to talk about indices, I'm going to tell you the rules that you need to know, such as if I gave you a question like this, hopefully you know that you can add the powers together. So as long as what I call the big number is the same, you can add the powers if you are multiplying them. If you are dividing them like this, then you subtract the powers. You do not actually divide the powers, you subtract the powers in that situation. If you had something like this, the answer is x to the power 6. Here, you multiply the powers when they are next to each other, like that. One example of this that I always like to show people, because I think they get it wrong all the time, would be something like this. Okay. In that situation, what a lot of people do wrong is they remember the previous thing I just told them, and they go, oh, there's a 3 and a 2 there, so that makes a 6. And they forget that when you say how, are you talking about the surds themselves? I can quickly explain this if you'd like to know, but I won't use smaller numbers. If that is x cubed, that is the same as x multiplied by x multiplied by x. And that is being multiplied by x to the power 5, which is x multiplied by x. Should use smaller numbers. Okay, right. That is the question. I'm sorry, the x's make this look really confusing. But what I've got here is x times x times x times another x, x, x. In total, that is 8 of them, which can be written as x to the power 8. That is why we add the powers together. That is the explanation of it, if that makes sense. In this situation, I want to use smaller numbers now because that's ridiculous. If I have that and that, let's just say, this, then it is x multiplied by x multiplied by x multiplied by x divided by x multiplied by x, right? That's x squared, is x times x. What we can do in this situation, because everything's being multiplied on the top and bottom of a fraction, I could cancel this x with this x, and I can cancel this x with this x, leaving me with x to the power 2, which is the same as just subtracting the powers. That's the explanation for it. Not that you really need it, but yeah, you go. That is the explanation. Um, and just to explain that last one as well, if I said to you x cubed squared, what does anything squared mean? It means that you multiply it by itself, right? 3 squared is 3 times 3. So x cubed squared is x cubed times by itself. And if we just think of the addition rule that I just said earlier, you add the powers together. So that's the same, if you want to get it quickly, is the same as multiplying those two numbers together. Back to this question. The thing that people do wrong here is they just multiply those together. I've seen a question about the activation energy thing. I was intending to do that. I'm going to do that in a second. Treat this as two different questions. You've got a 3 that has a power 2 on it, and you have an x cubed that has a power 2 on it. Just think of that power 2 as separately on those two pieces, which means that 3 squared gives you 9, and this gives you x to the power 6, which you then just join together. 9x to the power 6. And where that can, I want to make it even more complicated, if I said to you 4x squared y cubed, no, 4x to the 5 y cubed to the power 2. Imagine that was a question. Treat that as three different questions. We've got 4 squared, we've got x to the power 5 squared, and we've got y cubed, all being squared. The 4 squared is 16. This is x to the power 10. This is y to the power 6, and then just join them together. And that would be the simplified answer. But as I say, often people forget about the number at the beginning when they're doing these questions, so no, don't. That was what, there's more rules. There's more rules of indices. Okay, anything at all to the power 0, the answer is 1, as is about to be demonstrated. There you go. Okay, anything at all to the power 0, the answer equals 1. Then we have negative and fractional powers, which is a slightly more complicated version of this. Negative and fractional integers. Yes, that's the thing. Right. So how is it possible? I'm not going to explain how it's possible. It just is. Okay. Oh, I could tell you actually. I could tell you very quickly. If I said to you 6 divided by 6, what is the answer? It's 1, isn't it? Because, or if I said to you 7 divided by 7, the answer is 1. Or 20,000 divided 2,000 divided by 2,000, the answer is 1. If you divide something by itself, the answer is 1. If I gave you this question, x to the power 5 divided by x to the power 5, then if we just follow the rules of indices first, you can subtract the powers here, right? So that is x to the power 0, because it's 5 take away 5. But as I just said, if you are dividing the same thing by itself, it also equals 1. That's essentially why. The power 0, imagine where it's come from. It's come from the same thing dividing by itself, and that's why the answer is 1. Okay, negative and fractional indices. First things first. Right, I'm going to start with -1, okay, as a power. The negative, all that does is it flips over whatever number you have here. So if this number is a whole number, just remember any whole number is technically a fraction over 1. That's what it is. I know you don't see that and you don't think of it like that, but it is, okay? So what a negative power does is it flips over this number. So it becomes half. And that 1 would still be there, but to the power 1 doesn't do anything. That's why I'm just starting with -1 as an example. So all the -1 power does is flips over the thing, and there's nothing else to do after that. If I said to you 3/4 to the power -1, the answer is 4/3. That's it. It just flips it over. However, if I had said to you 2 to the power -3, let's just say, for the sake of it, then again, the first thing to look at is the minus. What the minus does is it flips over the thing that you've got. So the 2 flips over 2.5. Okay, but the 3 is still there. Right. When you have a fraction to the power of a number, what you need to do is make sure that you apply that power to the top and to the bottom. So it's basically having 1 cubed and 2 cubed. 1 cubed is 1, 2 cubed is 8, and that is the answer to 2 to the power -3. It is 1/8. Um, so the minus flips it over, and then whatever the number is, you apply that number to the top and bottom um, of the fraction. So if you do one more, let's do 2/3 to the power minus 2. So the minus flips over this fraction. The 2 is still there. And what we do is now we square the top and we square the bottom. So 3 to the power 2 is 9. And 2 to the power 2 is 4. Nth term. Yeah, why not? I'll do that. I must only do the linear nth term ones because the nth term is a quadratic thing, which our year 11s did, which is, yeah. 9 over 4 is the answer to that, firstly. Okay, so that would be 3 over 2. Again, you can check these things afterwards. Just make them up yourself. Do what I'm doing. So what was it? 2/3 to the power minus 2. 9 over 4. Okay, so flip it over. That's what a negative power does. Okay, fractional powers. When you have a fractional power, what you need to do is look at the denominator of the fraction. If the denominator is a 2, it means that you square root. If the denominator is a 3, it means you cube root. You don't really get much further than that, but a 4 means the fourth root, but you don't really usually see that. So the first thing to do in these questions is to look, where's go? Well, there's a 2 on the bottom. What that is telling me to do is square root this 16. Okay? I always put it in brackets because the top number is still there. So that is still, I know a 1 doesn't do anything, but I like to get into good habits and say, well, okay, we're going to square root of the 16, and then we're going to put the answer to the power of the top number. The square root of 16 is 4, and then that 1 is still there. The 1 doesn't do anything. So the answer to 16 to the power of half is 4. And the reason it's important to do it like that is because if I now said to you 16 to the power 3 over 2, the 2, again, is what we look at first at the bottom. It tells you to square root the number there. The 3 is still there. Don't ignore it. It's still there. So what we'll now do is square root the 16, which is 4. The 3 is still there. 4 times 4 times 4 is 64. I'm writing really big. I don't know why. Yeah, so the an squared plus bn plus c is a quadratic sequence thing. I will do one example of that now because we did do it in year 11. I'll do it. I'll do it in a second. Right. Okay. Shall be here forever. Right. So it's fine. 16 to the power 3 over 2 is that. Let me just do another example with a different number at the bottom, like 8 to the power 2/3. So this time there is a 3 on the bottom. That's the first thing you look at, the 3 at the bottom. The 3 at the bottom tells you to cube root the 8. Cube root the 8. And then the 2 at the top is still there. The cube root of 8 is a number that multiplies by itself and then by itself again to give you 8. That number is 2. This 2 is still there. 2 to the power 2 is 4. Let me do that with one more example. 27 to the power 2/3. The 3 at the bottom tells you to cube root of the 27. The 2 is still there, the top 2. Cube root of 27 is 3, because 3 times 3 times 3 is 27. And the 2 at the top is still there. And then 3 to the power 2 is 9. I wanted to mix that with fractional powers now. So one final example. 16 over 9 to the power minus 3 over 2. Okay. So if we follow what we said earlier, the minus flips over what you've got. So I'll do this without actually writing it again. So the minus just flips this over. So the minus effectively causes this to become 9 over 16. Then what we need to do is look at the bottom number. The bottom number tells you to square root everything. Okay, so we're now going to, if I'll just literally do this like this. So the 2 at the bottom tells you to square root all of this. Okay, the square root of a fraction just means that you square root the top and you square root the bottom. And I've obviously deliberately made these lovely square numbers. The square root of 9 is 3. and the square root of 16 is 4, that's what that's become. And the 3 is still there. Now, what we do is we cube the 3 at the top. 3 times 3 times 3 is 27. And we cube the 4 at the bottom. 4 times 4 times 4 is 64. And that is 27 over 64. The question originally has gone, but it was 16 over 9 to the power 3 minus 3 over 2. Yeah. 27 over 64. That's how you do it. That pretty much covers your rules of indices. Um, um, right, and that's that. Right, and then surds I will do again relatively quickly, but and what I might do as well, I'm going to direct you to some stuff because technically, again, I keep saying this every week, but you guys technically all have access to some videos I've made, which pretty much is everything I'm just doing right now. But some of you don't, but you should ask if you don't, but we do, you do. I just need to make sure I give it to everybody. A question on quadratic inequalities. Yeah, I'll get to that. Right, a bit of surd stuff, right? You cannot add these two surds together because the numbers are different. But if the numbers are the same, you can add them together. It's a bit like if I said to you, what's x add x? You would hopefully tell me the answer is 2x. In the same way, if there's these same two things being added together, we can put a 2 in front of them, and that's how many of them we've got. It's a slightly bad example. Let's change that to a 3. And that's a 3, and then you can see it more clearly. So the square root of 3 add the square root of 3 is 2 lots of the square root of 3. If I gave you a question that said something like 2 root 3 add 3 root 2, add 4 root 3 add 5 root 2. It's a little bit like having 2x add 3y add 4x add 5y. You can collect the like terms together. So you can collect those together because they're both something root 2. So 3 root 2 and 5 root 2 makes 8 root 2. You can collect these together because they are the same. They're both root 3s. 2 of them and 4 of them make 6 of them. So it's 6 root 3 add 8 root 2. The triple science topic videos, they're all there apart from the physics ones. So everything that you should need should be there. But be specific if you need to let us know if there's anything that you think is missing. I know the physics ones aren't all there because I haven't had time to make them all. But all the chemistry things should be there, including organic and calculations and stuff, and all the biology stuff should be there. It's just a case of finding where they are. Right, so that's that bit of surds. Then there is contact us and I will just make sure that you have access to it. Yeah, not here because it's just complicated to do it here, but just send us a message through something and I will just make sure. It just takes me a second to do it and I'll make sure it's done. Yeah, okay, yeah, I'll get to the chemistry thing. I have to actually do these things in order a little bit. Oh yeah, I'll also get that. Yes, the maths revision session. Fine. Okay, I will continue with surds in just a second, just because I'm conscious that some people are waiting specifically for the test stuff. So the question about energetic and endothermic and exothermic reactions. So I would make sure that you know the following, which is that on a graph of energy and time, this represents the graph for an exothermic reaction. The reason I know that's an exothermic reaction is because an exothermic reaction releases energy to the surroundings. Now, this line represents the energy that we begin with in the chemical reaction. It is the energy of the reactants. The reactants are the left-hand side of the arrow. We have reactants on that side, products on that side of a chemical equation arrow. So at the beginning, reactants, let's say we started off with this much energy, whatever that number is, it doesn't really matter. We finished with this much energy. This is the energy in the products. And now that, because that's lower, see, that's in line with a lower point on this graph, we have gone down overall. Because we've gone down overall, it is an exothermic reaction because we have lost the energy. An exothermic reaction is one where we lose energy to the surroundings. That tells me it is an exothermic reaction. Um, yeah, that's it. And there's another label to do in a second, but I'll do that. But then the difference between this and an endothermic reaction is that if I start here, if it's endothermic, then energy has to be taken in. So I should end up with more energy than I started with. So my finishing line should be higher than my starting line. You see how this line is lower than your starting line? The finishing line should be higher. And it looks something like this. Okay, so that is the energy of the products. That's the energy of the reactants. We've finished higher than where we started. That makes it endo. Finished lower than where we started, makes it exo. Now, there's a couple more labels that you need to be able to do for these diagrams. The difference between where you started and where you finished, in other words, this arrow effectively for this graph, so starting point to finishing point if you just vertically, and over here, this to this, those two describe the overall energy change. Okay, and then there's one other label which is to do with activation energy. The activation energy is from the starting amount of energy to the finishing amount, sorry, the starting amount of energy to the highest point you reach. So from there to there on this graph, or from there to there on this graph. Do you see what I mean? From where you started to how high it goes at the beginning. Both of these two are the activation energy. And these graphs never change. So it's not like it's different each time. It is identical every single time you see these. I won't be able to do direct and inverse proportion, growth and decay today. What we need to do is ideally send some questions to us before this session. Otherwise, I have to just pick at random, and I can't always get to every single thing. But I'm not only at direct and inverse proportion, growth and decay. However, I know that there are some maths videos that I have made on both of those topics. So what you need to do is send us an email requesting them, and I'll just make sure you have access to it. It's my fault that I haven't given access to everybody apart from who I remember. But technically you all have it, so this will be fixed. Right, that was that one. Let me go back to surds briefly. So the only other thing I want to say, I want to get to the slightly advanced bit of surds now. What you have to be able to do with surds is often simplify them. Now, if I told you to answer this question, the square root of 3 times the square root of 2, the answer is the square root of 6 if you have to simplify them. And sorry, that's the answer to that. Now, simplifying a surd basically involves working backwards from there. So for example, if I wanted to simplify the square root of 20, what I want to do is turn it into two numbers that times to give 20, such as the square root of 2 and the square root of 10. They times to give 20. However, when you do simplifying of surds, you want to make sure that one of your numbers is a square number, like one of these, and so on, right? These are all square numbers, right? 100, first 10 at least, right? So for example, if I was looking at two numbers that times to give 20, 2 and 10 do times to give 20, but neither of them are a square number. Are there any other numbers that multiply to give 20, of which one might be a square number? Yes, there is 4 and 5. So because you've now got the square root of 4 here, which is a square number, it can simplify to a whole number, 2, and then you just stick that onto it. So root 20 simplifies to 2 root 5. That's what simplifying surds is. Let's think of another example. 32. 32 can be got by doing the square root of 16 times the square root of 2. And because the square root of 16 turns into a whole number, 4, it simplifies to 4 root 2. I should also point out that technically surds should only ever be on a non-calculator paper now, because in theory, it just does it for you. If I do the square root of 32, it tells you it's 4 root 2. If I do the square root of 20, tells you it's 2 root 5, as I found before. So it does do that for you. There is one other aspect of surds, and not just because of the number of things I have to do. I'm not going to get to the other bit, which is called rationalizing denominators. Well, I'll do one example. Right. If I said rationalize the denominator, for some reason, don't ask me why, You are not supposed to have a third at the bottom of a fraction. It's to do with it being irrational and stuff. Anyway, you're not supposed to have it there. So what you want to do is change this to something that doesn't have a third at the bottom of a fraction. You can have it at the top, you just can't have it at the bottom. So what you do in this scenario is you multiply the top and the bottom by the thing you have at the bottom. And if you do that, you get 3 times the square root of 2, which just sticks together. And you have the square root of 2 times the square root of 2, which is the square root of 4, which simplifies to 2. And that has been rationalized. The third basically switches from being at the bottom to the top. And again, the reason why this should, in theory, be in non-calculator situations is because of the fact that if I type that into my calculator, it does it for me. It does the rationalizing bit for you. Right, done energetics, done that. There was a question about quadratic inequalities and quadratic sequences. Okay, I will just do this bit and then I will do the okay, you know what? Just in case anybody is just waiting for the fact that the most of you have tests this week and the ones that physically come and haven't started very recently. If you have started very recently, then you might not be doing it. But right, all I'm going to do, and you can watch this back later before the weekend, is just go through. So for the year nines, I would suggest that you make sure you know um, how a vaccination works, how what white blood cells do. Oh, you also have a verbal test, by the way. Remember that. I can't remember what's on that. White blood cells, yep, fine. Make sure you know what photosynthesis involves and how plants use glucose. In chemistry, you want to make sure you know that diagram about the endothermic exothermic reaction I just said. Um, Other than that, there's nothing too exciting there. Ooh, one question that we'll have to take out. You got to do a pie chart. Okay, but I think it's really easy, so don't worry about it. Fractional distillation of crude oil, that process you need to know. And in physics, there's some equations that they're given to you anyway, so it's not very difficult. Anything else? Stopping distances, thinking distance and braking distance and reaction time when a car's stopping. That stuff you might need to know a little bit about. There's an equation there. Yeah, in maths, you've got loads of angles, just loads of angles, loads of angles. Yeah. Oh, and there's some Pythagoras in there. Yeah, you should know that. Okay. For those of you in year 10, it must be quite similar. Yeah, stuff to do with white blood cells, vaccinations, photosynthesis. I mean, I'm just telling you the topics really here. It's not that exciting. Some stuff about hormones and some diabetes is in here because you'll have done a topic that involves some of that. Chemistry, again, energy changes like endothermic, exothermic stuff, organic chemistry, the whole fractional distillation thing, big question. And then the stuff to do with the graph. That's not going to be too much. Anybody asking me questions? By organ chemistry, you mean organic chemistry? Yes, yes. Fractional distillation of crude oil is organic chemistry. What is the point of verbal tests? It's to stress you out so that you ask me why you have to do verbal tests. Physics. I will tell you a proper answer in a second. For year 10, solid liquids and gases and the differences between them. Now, you know those pictures that you have of solid liquids and gases, like, show you, let me show you. So this kind of picture where you've got this. Now, you have to, one of the questions literally says that you need to compare these 3 diagrams in terms of their arrangement, their movement, and the energy of the particles. There is a 6-mark question asking you the differences between these pictures. This is in the year 10 test, just to be clear. I'm getting to the year 11 stuff. Yes, a little bit. Sorry. Nothing else too exciting there. There's some stuff about forces. There's The problem is some of this I can't tell you because it relies on you reading the question, right? And it's like a graph in the question or something like that, or data in the question that you have to interpret, which is what a lot of these exams ask you to do anyway. So not a huge amount. There's a bit on thinking distance and forces, um, things that increase your braking distance, thinking distance. Right. In maths, there's some mean, mode, median stuff. Um, Yeah, there's frequency tables as well, so bear that in mind. When you have a frequency table, you have to work out the mean, midpoints, and all that stuff. There is a cumulative frequency question on it. Then there is a circle theorems involving tangents question. There's more circle theorems, there's more circle theorems, there's more circle theorems, quite a lot of circle theorems, given that you did it last week, that should be easy. And that's that, right, for year 11. Um, I think a lot of this, we tried to focus more on things that are on paper one, but I might be wrong. So let me have a quick look. What's here? Um, there's a required practical. Photosynthesis required practical. That's all I can tell you as a hint. Then there's loads of stuff on that. There's quite a lot of paper one stuff on cells and things. Then there is a bit about the nervous system. And there is some ecology stuff at the end. Whoa. Peat bogs. That's a clue. Asmara, you are doing the test. You didn't start recently enough. Um, Apologies. Sorry, I've opened up the wrong one here. Not that one. Um, Sorry, biology, that was that done. Right, chemistry, what we got? We've got some organic chemistry in here. That's fractional distillation, all that stuff. There is some quantitative chemistry, easy quantitative chemistry, so I wouldn't worry about it too much. Um, yeah, and then like beginnings of chemistry, atomic structure and stuff like that. There's a little bit of that in there. Physics, energy, electricity. That same question on the solid liquids and gases with the particles arrangement and all that stuff. Um, yeah, sorry, but my fault. You will do the test. I think you made a mistake. You'll do it. It's just other people, but you can do. It's fine. It's just consider it as practice. Don't worry, but don't stress about it. It's a good chance to you to see what you know and what you don't know. There's no consequences to these things. There's radioactivity in there, like alpha, beta, gamma decay stuff. There's electromagnetism in there. So yeah, what we try to do is mix up quite a lot. So there's a bit of electromagnetism, the motor effect, that stuff. And then in maths, algebraic fractions, there's circle theorems, there's straight line stuff. There is some statistics, cumulative frequency, there is box plots, and there you go. That covers it. Um, Everybody in year 11 is doing the test. Just to be clear, I'm just speaking. This is awkward because I'm trying to speak directly to one person. It doesn't really work. Everybody, as far as you're concerned, is doing a test. Just put it that way. Unless you literally started about a week or two ago, in which case well, if you haven't been told about it, then um, I sent an email to everybody who should be doing it, so you'll be fine. But put it simply, everybody's doing a test. Right, and I basically told you what's on it. Right, that was that. What else have people asked me then today? There was a bit of biology. I've done that bit on thirds. Oh yeah, the verbal test, just so you know, the verbal test is we feel an opportunity to see whether you actually know the stuff. Sometimes the way a question is asked on a test can confuse you a little bit, but it gives you an opportunity to prove that you actually know your stuff. Like, for example, if I asked you how a vaccination works right now, then you should be able to tell me straight away without any real hesitation. Whereas in an exam paper, the question can sometimes be asked in a slightly weird way. You might misunderstand it a little bit. Your exam technique might not be perfect, but it allows us to compare exam technique versus knowledge, which is the benefit of doing a little bit. It's just a conversation. I treat it as a verbal test. Um, right. Somebody asked me quadratic inequality, and we've got quadratic sequences as well. So just one, I'm going to do one quadratic inequalities question, which is quite an advanced topic, so please don't stress. If I said to you to solve x squared, let me make this up, plus x minus 6 is less than 0. First thing you want to try and do is solve the quadratic equation in terms of factorize it if you can. Get the two answers that you normally get to. And if you can factorize it, great, because this does factorize to x plus 3, x minus 2. Therefore, the answers are minus 3 and 2. It's always the opposite of what's in the bracket. That's your first part of this. And that's the first part of it. And then What you then need to do, normally if it was an equals question, you just put equals equals and it's all deadly straightforward. But when it's an inequality, which is again an advanced topic, so don't worry too much about it, what you have to understand is what you have just found. You have just found these values, 2 and -3, which is where the graph goes through the x-axis. That is actually what you've just found. And the question now is asking you, where is that graph less than 0? It's less than 0 here, this section of the graph, where it's just below the 0 on the y. And basically, in terms of the x coordinates, it's therefore in that direction of that x coordinate and that direction of that x coordinate. So it's greater than the -3 and less than the 2. You should basically try and get up to here. There is technically one more thing you're supposed to do for this question, which is join it into a single line, but don't stress about that too much. I rules of series and parallel. Right. Okay. I'll try. I might not have time to do the series and parallel circuits. Let me see where we are. Okay. So, oh, quadratic sequences. Right. I'm going to do one question on quadratic sequence, and I'll explain this to you on Saturday. I know who asked this specifically. Again, but oh, I've got to make these up. I can't even make up a quadratic sequence. Let me find it. Sorry. Okay, the problem with this topic is that there are two ways to explain it to you. I am going to do the quick way. There is a longer way. A proper way, so to speak. I'm going to tell you a quick way to do it, which answers any quadratic sequence question correctly. And in the end, you will end up preferring this method, but you might get taught a different one to start with. So here is a quadratic sequence. And the question is, find the nth term of this sequence. Just a quick reminder of nth term stuff for people. If you have a sequence that was like, and I said to you, tell me the nth term of this sequence. The nth term is like a formula that will tell you any number in this sequence if you know what position it's in. For example, that's position 1, 2, 3, 4, 5. Now, if I wanted the number in position 100, if the sign is the other way, I'll tell you in a second. If it's position 100, then I don't really want to keep on adding 4, right? And continue all the way to get to where it is. There is a way to get to a formula that allows you to get to any number in the sequence. The way you do it for this kind of sequence, this is called a linear sequence because it's going up by the same amount every time. If I want the nth term of this sequence, you get to this number, put an n after it, then, this is the clever bit, you imagine if there was a number before this 3. If there was a number before this 3, then it would be 4 less than that 3, and it would be -1, wouldn't it? If there was. And that -1 just goes here. And that is a formula for the position of any number in this sequence. So for example, if I wanted to know what the 6th number in the sequence is, then I could do 4 times 6, which is 24, take away 1 is 23. If I wanted to know the 100th number in the sequence, I would do 4 times 100, which is 400, take away 1, 399 would be that number in the sequence. Let me do this, then I'll explain that inequality thing. For these kind of sequences, there is a trick, and I'm just going to tell you the quick way to do it now. The problem with a quadratic sequence is that it's not going up by the same amount every time. It's going up by 8, then 14, then 20, then 26. It's going up by different numbers every time. And so the answer, the nth term formula won't look like this. It's going to have an n squared in it. It'll be something n squared plus something n plus something else. It'll have potentially numbers here and here and here, right? It could have numbers there. So it's a more complicated looking equation. But there is a quick way to get to the answer, and I'll just tell you what that is. Firstly, the differences are different, right? 8, 14, 20, 26. But the differences between those differences will be the same. So you see how that's 6, and then that's another 6, and that's another 6. Right. So write that down as we've done here. Then all you do is you take these three numbers. Okay, I'll put that in green. These three numbers is all we need. 2, 8, and the 6. So 2, 8, 6. Now this bit won't make any sense for now, but I'm just trying to prove to you that it works. All you need to remember now is what I'm about to tell you is put 2a equals the number that you have at the bottom of whichever sequence you're doing, right? These numbers are not always going to be the same. Obviously, it depends on the question. But you will have three numbers in these positions. Put those three numbers here. Put a 2a equals before the last of those three numbers. Put a 3a plus b equals before the second number, and put a plus b plus c equals before the first number. This bit is what you just need to learn. If you learn that, you can answer any quadratic sequence question. And all you do now is you work your way up from top to bottom, bottom to top, right? If you divide by 2, 6 divided by 2 is 3. So my A is 3. Remember, I'm trying to find out what A, B, and C are. The A is 3. Once you know that A is 3, take it there and put it into there. 3 times 3 is 9, plus B is 8, which means the B must be 8 take away 9, -1. So my B is -1. Take the A and the B and put them where they go. So A is 3. We just worked out that B is -1, plus C equals 2. In this case, unusually, the C is 0 because 3 take away 1 is 2. 2 plus something is 2. So your C is 0. Once you've worked out A, B, and C, you've done the question because the question wanted you to fill in all of this. If A is 3, it's 3n squared. B is -1, so -1n. C is 0, so you need to write that bit in. That is the quadratic sequence. Nth term of that quadratic sequence. It's 3n squared minus n. It works every time. We'll do a bit more of these on Saturday for the person that asked. Going back to this question where you had a quadratic inequality where it was the other, where it was I gave you a less than 0 question. All I'll do now is change this to greater than 0. If it's greater than 0, it means that we're not after this yellow highlighted bit anymore. We want the bit that's above the line. So we want this section and this section. Let's see if I can highlight that. So we're after the bit where y is greater than 0, so the bit that's above the y-axis. In terms of the x-coordinates, that would be now in this direction of the -3 and that direction of the 2. So bigger than 2 and less than -3. It just swaps over, and the more you do of these, the easier it gets. Right, I think that's enough maths. If you have any other specific maths things, then just send us an email at some point, and then we can sort of plan and do some stuff for it. Let me just go back to the top. All of these questions. Okay. Somebody mentioned decay and somebody mentioned meiosis and mitosis. The question about Mendel's P's biology, I will discuss that with you on Sunday if that's okay, because I think I will be in Manchester this Sunday. So I will deal with that on Sunday if that's okay. Just whenever you've done the test, we'll talk about it. Difference in mitosis and meiosis, and then there was a decay thing, wasn't there? So I'll just do those two things, I think. I think I've run out of yeah. I'm not going to do the series of parallel circuits just yet, but we'll get to that with you. I'll arrange some time with you about that. So mitosis and meiosis. Okay, I'll just do a quick summary of this because I don't think this is that complicated. But a common question is understanding the difference between this thing called mitosis and meiosis. And those of you, oh yeah, we're going to do that differentiation. Yeah, we are. Yes, just leave it with me. We are possibly on Friday. Be prepared. So the mitosis and meiosis, that's what I was going to say. The main difference, and this is more of a, if you're doing AQA, it's a paper 2 thing where mitosis technically is in paper 1, but meiosis is in paper 2, which means that you can get a question in paper 2 comparing those two because they assume by paper 2 So you know the paper two content is paper one content is a bit weird. Um, Mitosis is basically, I mean, to put it simply, it's how our cells grow and repair. But the crucial thing that the way I remember this is that mitosis is all about making exact copies of a cell. So if I've got a cell, then at the end of mitosis, at the end of it, there's a process involved here, which I'm not going to go into too much right now. But there is a process when the cells, when the everything duplicates and they all line up in the middle and they get pulled apart. There's a few little specifics that you have to know. But if we're just focusing on the main differences between mitosis and meiosis, the key difference is that in mitosis, if I started with a cell, what I end up with is two of the exact same cell that I began with. They are identical to each other and to the cell that we started with, right? We're just making complete clones in mitosis. So you've got a cell and you're identically duplicating it to make exact copies of it. I will simplify this in terms of chromosomes in a second. Whereas in meiosis, sorry, that's mitosis. In meiosis, the end result of meiosis, keep messing this up. The end result of meiosis is that you start with a cell, but what you finish with is not the same. I don't know how to illustrate this properly, but what you finish with is not the same as what you started with. Because what you produce in meiosis are gametes, which are either sperm cells in males or egg cells in female. They are different. Your sperm and egg cells are different to all of your other cells, mainly because, as I have attempted to illustrate here, they contain half of your DNA. They're effectively half of a cell, sort of. Don't think of it like that. But they contain half of your DNA. And so they are not the same as what we started with. They are also, assuming these are two sperm cells, not the same as each other. Every single sperm cell and every single egg cell contains half of your DNA, but a different half, if that makes sense. So they will all be genetically different to each other and different to what you started with. So that's the main point of difference, okay, is that in mitosis, you're making exact copies. In meiosis, you aren't making exact copies. You are making only sperm and egg cells, depending on your gender, and those cells contain half of your DNA for obvious reasons. But let me just now explain this in a totally really weird way that I don't think you will have been shown it before. As I say, I'm not going into the details of the process of mitosis and meiosis, which is like the cells lining up, the chrome DNA lining up, pulled apart, and various things going on. I'm just focusing on the main differences between the two. In a cell of yours, in a nucleus, you have 46 chromosomes. That's what you have. So we all have. What happens during mitosis? If I want to make a copy of this cell, effectively what happens is, and again, don't think of this in terms of numbers, it's just an illustration for you. First thing that happens is that all of your chromosomes duplicate themselves. So those 46 actually, for a while, become 92. Then it splits in half. And if you split 92 in half, you get 46 and 46. And so you end up with what you started with because you have split something that had doubled to start with, if that makes sense. Like, it's very hard to explain this in a different way, but we've made it twice as big and then cut it in half. So we've ended up back where we started, more or less. So we've ended up with that. We call this a cell division when they split, right? In meiosis, however, the same thing happens initially. You've got a cell, all of the chromosomes double, so now you have 92. But they then also split, so you get 46 and 46. But then what happens in meiosis is that it has an extra division. So that 46 splits again into 4 cells, which have half of the number of chromosomes that you began with. Okay. And so if you have to answer a question about the differences between mitosis and meiosis, you could say that in mitosis, you produce cells with 46 chromosomes, whereas in meiosis, you produce cells with 23 or half the number. In mitosis, these cells that you produce are identical to each other, whereas in meiosis, these cells are not identical to each other. They contain a random 23 of your chromosomes, so they've got a different 23, if that makes sense. So it's all They're all different. The other key difference is that in mitosis, we had one cell division. In meiosis, we had a cell division here and another cell division here. We have two cell divisions and we have one cell divisions. I've effectively answered what should be a like 5, 6 mark question on the difference between mitosis and meiosis there. I think that's all I'll do for now. Just so is the process the same except the second division? Yes, basically it is the same except the second division. Um, there is an additional division. Otherwise, it is the same. I'm fairly certain. Everything happens the same. They all line up in the center. They get pulled apart. Then they line up again. They get pulled apart again. It's just there's the extra division basically. Right. Okay. Well, as I say, all of these things I'm just sort of summarizing quite fast, but in terms of the key things to try and remember is what I just mentioned there, because the kind of question that you get on this is the differences between them, and so knowing, and these are what the mark scheme wants, is understanding that sort of it's half the number. And also in mitosis, you produce what we call two daughter cells. In meiosis, you get four daughter cells. You see what I mean? Because you've got the extra division. You end up with four. These are all points that get you marks. Right. Lastly, let me just go to this little section on decay. I have to go reasonably soon due to yeah. Anyway. Right, let me just find the decay bit that's in the textbook. I can't even remember now exactly what it entails. There's a required practical, isn't there, as well? Um, yeah, I'll do this very briefly, but then when I do, given that the same person asked, but when we do the differentiation thing, which I will, it will be on Friday. We'll just talk about this then. Oh, I'm tempted to do it then. I'll just show you what's briefly in it, and then we'll talk about it then. Right. So in terms of I mean, like, okay, let me tell you what I think you should know about decay. Firstly, um, it is done by microorganisms like bacteria and so on, and the process of decay involves releasing carbon dioxide into the environment because the things that feed off whatever's decaying are respiring, like bacteria. They respire, they do this thing called respiration, which means that we are, is part of the carbon cycle. Essentially, we are recycling the carbon dioxide back into the atmosphere that has been collected by plants and stuff and animals eating them and so on. That's the gist of it, at least. Let's see what the textbook actually wants you to say. I've gone too far. Right, okay, and then the factors affecting the rate of decay is part of this. It happens. I mean, you probably already know this. I mean, it it's the reason why we have a fridge and a freezer, which is that things decay more when it's warmer. Because if it's cold, the enzymes don't work as quickly when they're trying to decay things. And then we, in the fridge and the freezer, it just doesn't. And so that's that. Oxygen availability. You may remember there's a topic of fossils somewhere within this, which is that one of the ways in which a fossil forms is that if it gets trapped somewhere where there's no oxygen, like a fly, there's a picture of a fly somewhere that goes into this stuff called amber, where no oxygen can get into it. And so there's no decay possible there because there's no oxygen for the bacteria to live off. And so nothing decays when there is no oxygen available. Similarly, water and stuff. Right. And then there's a practical. I'll talk about the practical with you then. Right. We will probably leave it there. But if anybody is the videos and things I mentioned, then if you just drop us a message, I will make sure that tomorrow morning I either WhatsApp or the email, whatever, I will make sure that tomorrow morning I have arranged for you to be able to at least access this. It's not, I mean, it's all right. I need to, I'm changing it over the summer a little bit, but I'll just tell you what it looks like so everybody's somewhat familiar with it. You have a login on our website. I'll make sure you have a login if you go onto it. Um, got my own password. Right, you get something that looks like this, where you've got something for combined, triple. I appreciate it's not complete, the triple one, but it's virtually there. I've got a foundation level maths thing and a high level maths thing. If you go into any of these, you will have something that says biology, chemistry, and physics. If, for example, you wanted to revise, for example, the stuff to do with disease ahead of the um, test, for example, then there is a video. They're all like 20 to 30 minutes long, and I just kind of go over some notes and highlight things. And I'm not playing it because I don't like my voice, but there's some notes and stuff that go with it. And then same with plants and stuff. So all of these things are made, and same with maths. So, for example, someone was mentioning direct and inverse proportion. I'm fairly confident somewhere in here, I have no idea where, somewhere it'll say direct and inverse. Somebody asked me to organize these in this way. I don't really like it, but there, direct and inverse. There is a video I made on it. So it is. There's a lot of them there. Clearly, with maths, you can't do absolutely everything, but I can always add to this. This is the whole benefit of this. I can add to these things as we go. Anyway, message us if you want that, but you technically are supposed to have it. We just haven't quite rolled it out to everybody yet. Right. I think that's enough.